What's up, everybody? Today we're going to do a transformation cheat sheet. So, we'll start with translations. So this should look pretty familiar. X values control your right and left, right? So if you move up, if you move to the right, that's a positive change. If you move to the left, that's a negative change. Y's control your up and down, so up is a positive change, down is a negative. So then I'm just going to make up a couple of rules in words, and then we'll kind of talk about what arrow notation means. So for instance, the first one I'm going to say is translate 3 left and 4 up. So what arrow notation means is that you take your pre-image, which is going to be your X and your Y, and then you draw a little arrow, and then the arrow kind of says, this is what I'm doing to it, and then you're going to get your outcome over here. So for instance, translate 3 to the left. So I'm going to take my X value, and since left is negative, I'm going to subtract 3 from it. Then I'm going to take my Y value, and since up is positive, I'm going to add 4 to it. So I'm basically taking my pre-image, doing the translation, and this is what will happen to the point. Okay, let's do one more. So translate 7 right and 2 down. If I could spell, it'd be great. And 2 down. So again, I'm taking my original point here, X comma Y. I'm doing my translation. So 7 to the right, since right is a positive change, I'm going to add 7. I'm going to take my Y value, and since it's going down 2, that's a negative change. So that's how I would show it in the arrow notation. Okay? Alright, then we're going to go on and talk about reflections. So the first thing I want to talk about is horizontal lines. So this could look like your x-axis is a horizontal line. Or also, if you have like y equals some number, that's going to get you a horizontal line as well. So what's going to happen is when it goes across the x-axis, the x is going to stay the same, and you're going to have the opposite of y. And then we also have lines, vertical lines, where this is like your y-axis, or also you could have like x equals some number, and it will get you a line that's straight up and down. What will happen here is you'll take the opposite of x, and the y stays the same. So this one's a little bit trickier than the translation. So first, I'm going to do a reflect across the x-axis. So all reflecting across the x-axis does is it takes our original point, and then once we reflect it, the thing that changes is the y, and it changes to the opposite value. So if it was, 2 in the original, once you flip it, it's going to be -2. All right. Then our next one, let's reflect across. Wow, I am just really bad today. I know there's an extra C in there. Reflect across y equals -3. So this one's a little bit trickier. X, y, so our first point, and then we're going to reflect it across y equals -3. And here's what's going to happen. We're still going to have x and the opposite of y, but then there's this extra thing we have to do. So since with reflections we're counting to the line of reflection and then past it that much, we have to take this number and double it and then tack that on to our change here. So x and then the opposite of y -6. And I'll show you guys why this works. So I have I'll graph right here, y equals -3. And then I'm going to take my point, and let's just say it's right here. So that point is 1, 2, and -5. So my first point is 2, comma, negative 5. So then what I have to do to it is my x is going to stay the same. So it's still going to be 2. But then I have to take the opposite of y. So the opposite of negative 5 is positive 5. So that would be there. And then I have to subtract 6 from that. So 1, 2, 3, 4, 5, 6. It would be right there. Okay? And just like how we learned to graph them, we would go 1, 2 to the line of reflection, and then 1, 2 past it. Okay? So this becomes negative y minus 6, which is, comma, negative 1. Okay? So this one is definitely a little bit trickier. All right, then let's do the next one where we're going to reflect across the y-axis. And when we reflect across the y-axis, our original point, then we reflect across, we're just going to take, instead of having the opposite of y now, we have the opposite of x, and the y stays the same. And then our last one here, we're going to reflect across x equals 7. Okay? So x equals is going to get you that up and down line like this. If we take a point from that and we reflect across x equals 7, so this time we're going to have the opposite of x, right? So opposite of x. And then what we have to do is, again, since when we're reflecting, we're counting to the line of reflection and then past it, we have to take this number and double it. So the 7 times 2 is 14. So we add 14 to that. And then our y just stays the same. Okay? And then that is it for the rotations, reflections, so let's get to the rotations. So a couple things you got to know when we're dealing with rotations is first, let's talk about clocks. So when we go this direction, around this way, this is counterclockwise. And then when we go this way, that would be called clockwise. Okay? So we need to know those two things when we're rotating to the left or when we're rotating to the right. Okay? All of our rotations are going to be probably about the origin. Okay? And this is how this works. Okay? So, for instance, if I say 180 degrees clockwise, so 180 degrees clockwise would go from here halfway around the circle, which would be down at the 6. So that's also the same thing as 180 degrees counterclockwise. You would end up in the same spot. So here's what happens when you do this. Your original point of x comma y becomes the opposite of x and the opposite of y. All right, then our next one we're going to talk about is 90 degrees clockwise, which is the same thing. So 90 degrees clockwise to get to 3. We could also start here and go 90, 180, or 270 counterclockwise. So we'll say 90 degrees clockwise or 270 degrees counterclockwise. So here's what happens with that. You take your original point of x, y, and this one's a little weird too, is your x's and y's switch spots. So you get y first, and then you get the opposite of x after that. So, for instance, if this point was 3, 4, once we rotated 90 degrees clockwise, the y would take the first spot, it would be 4, and then we'd take the opposite of 3, which is negative 3. So it would be 4, negative 3. Kind of tricky. Then this last one, 270 degrees clockwise. And the same thing would be, so 270 degrees clockwise would be 90, 180, 270. We'd end up there. We could also say that it's just 90 degrees counterclockwise. So 90 degrees counterclockwise. They're the same. All right. So we'll start with our point of x comma y, and then what happens when we do this is, again, our x and y switch spots, but we're going to get the opposite of y and then x. Okay? And then that is it for our cheat sheet today. Thank you guys for watching.